Hello, guys. So, this is the next part of the series in which I am going to explain the detailed solution of question paper of GATE Biotechnology of year 2020. Right? So, the next question is question number 22, that is to facilitate mass transfer from a gas to a liquid phase, a gas bubble of radius r is introduced into the liquid. Okay. The gas bubble then breaks into 8 bubbles of equal radius. Upon this change, the ratio of the interfacial surface area to the gas phase volume for the system changes from 3 by r to 3n by r. The value of n is okay. So let's see the solution. For solving the question, everything is not important. This is important concept that to facilitate mass transfer from a gas, the first line is important for the concept, but to solve the question, that is not very important. To solve question, this is important. Okay, so let's solve the question. Suppose this is the bubble, bigger bubble. Let's say bubble 1 or system 1. It breaks into 8 smaller bubbles. 8 smaller bubbles. Let's say the bigger bubble has radius r. Then the radius of the smaller bubble will change into 1 by 8 of r. That is r by 8. Right? R by 8. Now call this small bubble, take one bubble for instance, and call this system 2. Okay. Now, till this, I think everything should be fine. Now go to the next part. Uh, system 1 for system 1 for system 2. So in question, it is given the surface area to the volume ratio of system 1 is 3 by r. So let's find the this ratio. We don't remember this. Let's suppose I don't have this ratio. Just we have the data given is the surface area of bigger bubble. Surface area to the volume ratio. Okay, so find out the surface area S. Let's say S of the bubble is. If you remember, the surface area of the sphere is 4 pi r square. Okay, similarly, surface area for system 2 will be 4 pi r by 8 whole square, right? And the volume will be 4 by 3. Remember this, pi r cube. V2 will be 4 by 3 pi r by 8 whole cube. Okay, now we have to find S1 by V1. So see, 4 pi r square by 4 by 3 pi r cube. So 4 pi cancel, r square cancel, that is now 3 goes to upward, that is 3, and r remains downward, that is 3 by r. Okay, so this is for system 1. So I have taken this to system 2, but this is for system 1. So let's make it phrase. So yes, For system 1, S1 by V1 that we found is 3 by R. Also, it matches from the data given. Now, for system 2, S2 by V2 is, see, just remember I'm going to erase something. No, yes. Hmm. Just erase it. So the ratio is S2 by V2 equals to 4 pi r square by 8 square, right? Into, yep. So the value of volume is 4 by 3. 3 goes upward, remember, pi. So I'm writing this in here, pi r cube, sorry, let me, 4, 3 goes upward, pi r cube by 8 cube. Now 8 goes upward, right? So I'm writing this here, 8 cube. Okay, so again 4 pi cancel, r square, and here r cube, so r remain, and now 8 square and 8 cube, so 8 remain, so 3 into 8 by this r. Okay, so this is for system 2. The ratio is 3 into 8 by r, or 24 by r. So what is extra? 8 is extra. 8 multiplied by 8 is extra. This is the value of n, right? Okay, you can just compare. So erase all. 3 into 8 by r equals to 3 into n by r. Everything goes, n equals to 8. Okay, so this is the solution. Now go to the second question, question number 23. The largest eigenvalue of the matrix 4 minus 2 1 1 is, okay, so just going step by step. First, we should know what is eigenvalue or eigenvector. So suppose this is vector v. So when vector v is acted upon by a matrix, remember, by a matrix, I am calling matrix A, then it gives the vector itself multiplied by some constant, say lambda, I'm saying constant. You can call c or something, it's just notation, and lambda is so popular here, so I'm using lambda, right? Now, so this lambda is the eigenvalue, called eigenvalue of vector v, and this is the eigenvector. Remember? Now see, here I've written, see, this is the equation, and A is the n by n matrix, V is non-zero. Okay, so remember, non-zero means its value is not zero, and it is a vector. Lambda is scalar. So okay, everything is given. Now see the next part. Now try to arrange this equals to lambda v. So what we get minus lambda equals to 0. Okay, so there is no confusion till now. Now going to the next step. What is the next step? Taking v vector common. V vector common, a minus lambda equals to 0. Then a minus lambda equals to 0 upon v vector. V vector equals to 0. Okay, so here there is a catch. So let me erase all. First, a minus lambda equals to 0 we got, right? But see what I said, a is a matrix. Is a matrix, right? Suppose as in question, a equals to 4 minus 2 1 1, and lambda is a scalar value. Value means 0, sorry, not 0, not 0, 1 2 3 or 3.5 or anything, digit or integer or something, right? So you can't subtract. So just to make it into a matrix, we multiply it with a unit vector. Sorry, unit matrix. The value of the matrix is 1. So there is no change in the value of lambda, right? And it changes into matrix. So a minus lambda into unit vector matrix or identity matrix I equals to 0, right? So now you understand how this equation comes, correct? Now understand what is identity matrix. So identity matrix is n by n matrix, 2 into 2 or 3 into 3, where diagonal elements are 1 and non-diagonal elements are 0, correct? And so on. 0, everything is 0. Everything is 0. So what is the identity matrix for 2 into 2 matrix? That is 1 0 0 1, right? See, the diagonal value is 1 and non-diagonal is 0. For 3 into 3, this is 1 1, sorry, 1 1 0 0 0 0 0 0, right? So let's write let uh, yes. This is the identity matrix, and in question it is given only 2 into 2 matrix, right? So the value of identity matrix is 1 1 0 0, this. So now multiplying it with lambda into I equals to lambda into 1 is lambda into 0 is 0, lambda into 0 is 0 again, lambda into 1 is lambda again. So this is the product. Now putting this value into the equation, a minus lambda I equals to 0, a minus 1 0 0 1 equals to 0, right? And now put the value of a here. What is the value of a? What was the this was the this was the value 4 1 minus 2 1 minus lambda 0 0 equals to 0. Correct. Now solve it. 4 minus lambda is 4 minus lambda, minus 2 into 0 is minus 2, 1 minus 0 is 1, 1 minus lambda is 1 minus lambda. Now see here, everything is given. See, this is given. Now how to attain this? This is power lambda square. Lambda square. This is lambda square. So how to solve this? How to get into this? So see this. The final product after my subtracting is this one. So I am taking this equation directly. Yes, 4 minus lambda minus 2 1 1 minus lambda equals to 0, right? So now see this. This is multiplied by with this number, and this is multiplied with this number. So actually, after multiplying, there is a sign convention that we have to use plus or minus before the product of this number. So for to remember that, I have trick, as I'm a biophysicist. So I remember this. Right. I remember this like that. This like going downward is an spontaneous process, like falling from a falling something, like falling free falling body, hmm. Dropping ball isn't spontaneous, so no release of energy. So I'm taking this plus, and going upward is cost. The energy cost is needed there, so I'm taking this minus. Okay, so 4 minus lambda into 1 minus lambda, a plus sign, and this minus 2 into 1, minus 2 into 1. Here I need to put minus sign, equals to 0. Now solve this. Solve this. This is simple. Equals to 0. Oh, sorry. Actually, I'm using smartphone, so this can I don't have lots of space, so I need to erase every time. Right? This is the equation. This is the equation, and just multiply 4 into 1, 4 into minus lambda, lambda in minus lambda into 1, minus lambda into minus lambda, and then I think this is solvable, right? This is solvable, and after solving this, you will get the value of lambda is 2 and 3. Hmm. And out of this, the largest is 3. So answer will be 3. Answer is 3, right? Now going to the next question. Next question is normal random variable has mean equals to 0 and the standard deviation equal to 3. The probability that on a random draw the value of this random variable is greater than 0 is. Okay, so they see this. First make the uh, graph of random variable. This is the graph of random variable. This is the mean is equal to 3, sorry, 0, and this is where first sigma falls. This is second sigma, and so on. So the value of first sigma, value of sigma is 3, right? Here it comes minus 1 sigma, here it is minus 2 sigma. Okay, now let us erase this, only keep the important thing. Okay, yes. Now see, I so sample is one sample is drawn. So random sample. So if it is a random sample, it is a random sample, then it can be drawn from here, it can be drawn from here, it can be drawn from here. Chances can be, it can be negative, it can be zero, it can be positive, right? Everything. But it is said that what is the probability that it is positive, that it is greater than zero, or it is positive. So now see how we solve this. Actually, to find that it is drawn from here, not here and not from this line, we need to find the boundary value that it goes to the minimum. The minimum value is 0 up. So it can't go to the 0. The value of sample cannot be 0. Value of sample should be more than 0, right? So 0 is the x, say, right? And now I'm looking how much it deviates from the mean. So x minus mu, and how much it can spread. It can spread how much? The standard deviation denotes the spread, right? So to find how much it can spread, we have to just divide it from the spread, that is sigma, and we need to find the value. It should be greater than 0, the probability of this is the answer, right? Now see this, arrange. What is the answer? Answer was x minus u, I'm sorry, mu by sigma greater than 0 is the answer, right? So this is what we call z z score, right? So we can say p z greater than 0 is the answer. Now see, uh, z score, we find, we get a z table, z score table, where the value, the probability is given for every z score, right? But there is a catch, that in that table the probability of z less than x is given, not greater than x, right? So how x or y is, I'm taking any random value. So how to find this? So see this. This is very easy actually. Uh, what is the sum of the probability? 1, right? So if it is given, and if I have to find this, then the sum of these two will be 1, right? So this is equal to 1 minus pz is greater, sorry, probability of z greater than 0 is equal to 1 minus probability z less than 0, right? This is the answer. And you can find this x minus mu by Z score value, you can find this easily. The value of x is 0, mu is 0, sigma is 3, so z, the value of z is 0, right? And the probability of z less than 0 is 0.5, which is known. Okay, so 1 minus 0.5 is 0.5, correct? So now go to the next question. The next question is, variable y is a function of t. Okay, variable y is a function of t, and y, the value of y at t equal to 0 is 1. Value of y at t equal to 1 equals to 2, correct? Then what is the value of dy, dy by dt? And the range is given from 0 to 1. T ranges from t0 to t1, correct? So now see this. What is dy means? Y2 minus y1, right? What is dt means? T2 minus t1, and dy by dt means this, right? So okay, and what is the value of t2 given? This is the t1 initial condition, and this is the t2, right? So t2 is 1 minus t1 is 0, right? And what is the value of y2 at t2? That is y2. So let me write this correctly. Y2 at t2 minus y1 t1, correct? Then what is the value of y2 at t2? 2. What is the value of y1 at t1? 1 minus. So what is the answer? 1. Okay, so easy. Now go to the next question. The next question is, a block of ice at 0 degrees Celsius is supplied heat at constant rate to convert ice to superheated steam. So um, ice to liquid, liquid to vapor, or and vapor is again heated so that the temperature rises. Okay, this is the first line. Which one of the following trajectory correctly represents the trend of the temperature of the system with time? Assume that the specific heat of the H2O is not the function of temperature. So see, suppose here is the temperature. Here is the what we state of matter. State. This is I can correspond. C, I say, correspond to the state of matter, right? So suppose this is the zero value, 0. I'm making minus 1 or minus here, okay? Or minus 1. The value is minus 1. Suppose, so do you remember what is the state of water at 0 degree Celsius? It is ice or water? It is actually both. At 0 degree Celsius, ice starts melting, and again at 0 degree Celsius, liquid water starts freezing. So at this temperature, you will get mixture of solid and liquid both. So when heat is supplied, so remember, this is the solid. All particles in the solid are closely packed. closely packed. And in liquid, this is um, loosely packed. And in gas phase, this is more loosely packed. Remember this kinetic theory of gases? Yes. So just remember this thing. Okay. Now see. Let's let me take this one. So at 0 degrees Celsius, when heat is provided, the heat will be used in dissociating this particle away from each other, right? This particle, it will take away and make it more away, and transform it into liquid, right? So this will only change the state when heat will be supplied at 0 degrees Celsius up to a point where all ice melts to a liquid, correct? Then after that, it will start raising its temperature. The temperature rises, the temperature of the liquid rises, start rising, start rising. This is how we got get. Now let me erase this part. Now see, and at this point, suppose uh, 100 degree is achieved. 100 degrees achieved at this point. So what will happen? The liquid water start vaporizing. So one water, two water, three water, 4 mole of water, and all water starts vaporizing, vaporizing until all water gets transformed into the gas. The temperature will not rise, right? And when all water is transformed into vapor, so remember, this is when all ice, this is the point when all ice transform into liquid. So at this phase, only liquid is present. Here, liquid and solid is present. Here, liquid and gas is present. At this point, when all liquid is transformed into gas, its temperature will rise automatically, and everything will be gas. So, how this trend goes? This goes like this way, right? Remember this and see what is the answer. Uh, See, this is what we got from the explanation, and this is the answer. Okay, so now let's see the next question, or yeah, let's see the next question. Question number 27. The DNA sequence shown below is to be amplified by PCR. Which one of the following pair of primers can be used for the amplification? Okay. Remember, synthesis, RNA, DNA synthesis all occurs from 5' to 3' direction. Yes, remember? So if synthesis, the new the direction of the new strand is 5' to 3 strand, then the old strand is 3' to 5 strand, right? So if you just remember this, then see where is the 3' to 5' strand? This one. So this is the strand for which primer will be formed. So remember, the primer that is formed here, This will be forward primer. Another primer will be needed, that is called backward primer. That will travel in this direction. Okay, and again it will read from 5 dash to 3 dash, and we need a template strand 3 dash to 5 dash, which is here. So this is the backward primer strand. Template for backward primer strand. So now easy. You can solve. First find the what um, complementary of this sequence. The complementary will be, its complementary will be the upward arrow. So see the sequence of the upward and match which what is the right option. GCTA, GCTA, the B option, and GCTA D option. Out of B and D, I have the correct option answer. Now this is the uh, template for backward primer, right? So we need to find the complementary. So the complementary is this one, and we have to find the this sequence, and we will have the answer. So we see 3 dash is G C G C, sorry 5, it is G C G C, this one D C D C. So the answer should be 5 dash, then G C G C, yes, G C G C. This is the answer. True. See, I think you are confused in this one. So see this. Hmm. Yes, see here. This is the template strand, right? T T dash dash dash, and G C G C, right? Dash. So 5 dash will be G. So start the new strand will be read from here, G C, from 5 dash. See here in the 5 dash we have G C G C. So that's why this is the right option, and this is in B option. So B is the correct answer. So now this is all, guys. So I will be making the next video where I will be discussing more questions. Till then, thank you.